Hello, Facebook tonight. All right, welcome everybody. We are going to talk about one of the biggest things in math education, multiplication facts. How can we help students get them to stick even more than we ever have? Are multiplication facts important? Of course they're important. But what are the best ways to help get students so that they really own them down deep and that it's not just a surface level memory thing, or even more important, it doesn't become a stressful tension kind of thing that then builds anxiety and then kids hate math more and more. So what are some ways that we can really help students grab those multiplication facts and hang on tight to them? So I'm going to share 3 ideas tonight, y'all. We can't do everything. Facebook Live, it's kind of a short, sort of informal venue. We're going to do 3 of my top ideas for helping kids really own those multiplication strategies. All right, welcome everybody. So glad to have everybody on tonight. Maybe read the instructions if you want to comment. There's a little thing you have to do because I'm using StreamYard tonight because it allows me to share my screen in just a minute. So y'all, let me give a little bit of background here. Just this little bit that says, I think there's kind of 2 camps when we think about multiplication facts. There's sort of this camp that says, don't make kids memorize them. They just need to understand multiplication. Just make sure that they understand what it's happening, and then they can take as long as they want to figure it out, no problem. And then there's this other camp that's like, forget all that. We're just gonna rote, practice, and we're just gonna really help kids get it, like memory, and we're gonna sing and we're gonna dance, we're gonna rap, and it's all about rote memory. What if neither of those camps is the best approach? What if instead we sort of bring the best of those both worlds together? I'm going to show you 3 ways to do that tonight. So 3 ways that we can really help kids understand the facts, like really know the relationship between them, that if they don't have one, if they can't remember one, that they have some strategies to figure it quick enough in a multiplicative mathy way. But at the same time, we're also helping kids have those facts at their fingertips so that they're not fumbling around for them, or they don't look at you and go, I don't know that one. But that they know that the facts are figure outable, just like the rest of math is figure outable. We need kids to know that the facts are figure outable, but we don't want kids fumbling around and not being able to get a fact for like a long, arduous amount of time. But we also don't want kids finding facts with unsophisticated thinking. We want to build their sophistication. We want to build neural pathways in their brains so that the facts become automatic. What are some ways we can do that? All right, I'm going to share 3 ways with you tonight, 3 of my favorite ways, and then also share a surprise at the end of this Facebook Live, some even more really cool learning in store for you. All right, super cool. We got a bunch of people on tonight. Again, make sure that you sort of read those instructions in the comments. I think you have to click something and then I can see your comment. So you're welcome to comment as we go. Let's start with number 1, probably one of my favorite and most important ways that I'm going to suggest that you work with students. And I call that problem strings with ratio tables. What do I mean by that? All right, see, isn't that cool? I can share my screen there. So I'm going to be able to write on this screen a little bit. So what are problem strings with ratio tables? Let's break that down a little bit. So a problem string is a string or series of problems in a very particular order, very purposefully planned to help create relationships and connections in the learner's heads. We're going to use a model called a ratio table to help kids build those multiplication facts. Let's do an example. So I'm going to take a most missed fact, like, I don't know, like 7s or 8s or 6s or 9s. We're going to pick one of those and we're going to do a problem string with modeling on a ratio table. So let's say that we were going to say, I don't know, take one of those most missed fact, like 7s. And let's say, hey guys, we're going to talk about bags of apples. And so maybe I should also put a little asterisk here in context. For sure to introduce these first few problem strings that I do with students, when I introduce this idea, I definitely want to be in context. So the idea of I'm having bags and I've got apples. And I'm going to tell you that in that bag, I've got 7 apples. Everybody picture that. I've got bags, I've got apples. Everybody good to go? Okay, cool. So I've got one bag has 7 apples. How many apples would 2 bags have? Now, I'm not going to wait very long on that and let kids, if they need to count, or hopefully just add at the 7 set. A lot of kids know double 7. So if you double the bags, then you would double the apples. Oh yeah, that makes sense. Okay, so 14 apples. All right, cool. Then I might ask students, what if I have 4 bags of apples? How many apples do we have? 4 bags. Let kids sort of think about it a little bit, whatever they need to do. If I'm teaching multiplication, hopefully I don't need to do a whole lot of work with 14 and 14. But if I don't have kids thinking additively, I might do a little additive work off to the side to help kids think about 10 and 10 and 4 and 4. Pretty soon they're going to say, if I double that number of bags, I'm going to double the number of apples. Katie, totally. If we can stay in context, it's going to really help students. Y'all, maybe you might disagree with this. I hope not. But I have interviewed several adults who said to me, that if they would have just known when they were sort of taught the multiplication facts that this is what it means, it's like I've got 1 bag has 7 apples. How many apples do 4 bags have? They said to me, literally, they thought 4 times 7 was this unexplainable. I just had to memorize it was 28. I needed to sing a song or rap. Like there was no way that they could figure it out. They really thought it was just this like crazy thing that didn't have any connection to life. So the more we can put things in context, the more kids will be like, oh, this is what it means. Okay, got it. But then it's not enough to just have the meaning. Now we need to put some practice to it. But could we put some really meaningful practice like this problem string? So now we've got 4 bags of apples. Then could I ask kids how many apples are in 8 bags? Can we see a pattern? Yeah, I'm literally trying to get kids thinking about how they can double and double to get 4 and double, double, double to get 8. Can you double 28? Now you might have to spend a little bit of time here when we're thinking about doubling 28. And I might want to ask kids, how are you doubling 28? What are you thinking about? And some kids are going to say, I'm thinking about doubling 20 and 8. And so if I double 20, that's 40. And if I double 8, that's 16. So if I add the 40 and the 16, that's 56. Is that double 28? So if I sort of double each of these, double, 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 then sure enough, yeah, that's a way to do it. But don't stop there. Like, see if there's other kids that are thinking about doubling 28 any other way. Like, is anybody thinking about doubling 25s? Ooh. Could that work? Like 20 isn't, if I'm trying to double 28, but isn't 28, 25 and 3? So could I double 25? That's not too bad, right? Quarters. We want kids to have that relationship. Double 3 to 6. Sorry about that. And then sure enough, that's also 56. Or is there a third way? Could kids think about 28 as 30 minus 2? Could they double the 30 and double that 2 and then subtract 60 minus 4 to get that 56? Whoa, like all these connections, and we're sort of helping kids like really think through that just doubling 28. So now I've got kids thinking about 8 bags of apples, and that's going to have 56 apples. Then I might say, all right, so 8 bags has 56. How about 7 bags? So it's not always like they don't have to go in order. Ratio tables can go in whatever order I want them to, as long as I'm sort of making sense of what's happening. No naked numbers. Give them context close. That's cute, Laura. The word times really tells us nothing. Context matters and makes sense. Sure, I might say it tells us nothing, but it can tell us even more when we've started in context and then we layer in the word times. And then like all this sort of meaning that kids have been building, then we can kind of attach to that word times. Cool, Amanda. Nice. I love it. I love it. Okay, so now that they have 8 bags for 56, can we use 8 bags to help us think about 7 bags? That'd be one way to do it. So I might have a student share. Yeah, I've got 8 bags. So if I subtract 1 bag, now notice how I'm modeling that thinking. 8 subtract 1 would give me 7. Then am I going to take 56 minus 1? Ooh, I did 8 bags minus 1 bag. Therefore, I have to do 56 minus the apples in the bag, right? So what's 56 minus 7? And we let kids think about that. Is that 49? Cool. But I also might have kids thinking about something else up here to find those 7 bags. Could they think about 4 bags and 2 bags and 1 bag? Is that 7? Sure enough. And they add those together. Well, could they add 28 and 14 and 7? Sure enough. And they could do that work. And either way, we're going to get 49. We got kids sort of thinking about what these mean. And then we can practice by keep doing problem strings just like this. Let's see. That might be, I could end there, but I might do one more, kind of depending on how long that took. We want problem strings to be sort of mini lessons. They're kind of bam, like we sort of do them in 10 to 15 to 20 minutes. We don't want them to drag on. We want kids to know that when we're doing a problem string, they're like, oh, okay, this is cool. This is where all these relationships are happening, and I can think and I can just use what I know. But I might keep going. I might say, how about 10 bags? Now, depending on where you are, if you're in third grade, kids might not know the times 10 pattern yet. So let them use what's up there. You might have a kid say, well, I've got 8 and 2 bags. You might have a kid say, well, I've got 7 and 2 and 1 bags. Oh, you got anything else up there? I could add the 4 and the 2 to get 6 and then add it back to the 4. I mean, lots of different kind of things that kids could do. And then notice when we find that 70, notice it, go, huh, like that's interesting that 10 times 7 is like 7 tens, right? Because 7 tens, if I count 10, 20, 30, 40, I get up to 70. That's interesting. And just sort of write that down, like 10 bags of apples that have 7 apples in it is like saying I had 7 tens, like 7, 10, or 10, 20, 30. I count all the way up. That'd be 70, would be 7. That's interesting. Note it, just like notice it and let kids sort of like keep seeing it and keep seeing it. And then you can discuss it more and more. And then I might end this problem string with something like, well, what if I only wanted 9 bags of apples? Well, how many apples would be in 9 bags? What are all the ways that kids could use? And then after they do things like 7 bags and 2 bags or 8 bags and 1 bag, then I might like, did anybody use the 10 bags? Could you use 10 bags minus 1 bag? Whoa, 10 bags. Is that, what is 70 minus 7? Right? Could that actually be could that, all of a sudden something just looked wrong for me. I don't know why. Sorry. So could that be a strategy? Now, if I know my partner's of 10, I don't even have to do this subtraction. You guys, I don't want kids over here going like this. Okay, let's see. No, I don't want that. No, I want kids thinking about, well, if I'm at 70, can I like just subtract 7? Oh, well, what is 70 subtract 7? Well, I know 60's down here, right? And so that, oops, I didn't draw that very proportional. Let me try that again. 60's not. If that's a 7, then 60 is going to be there because that's just going to be a little 3, right? And so, oh yeah, that's going to be, I want them thinking about those combinations of 10. Very important. If I've got any third grade teachers on tonight, make sure that you're really helping kids own those partners of 10. We have a routine called I Have, You Need that can help you with that. If you guys want to just Google I Have, You Need, it'll come up with a great blog post with some video to help you really get down those partners of 10. And so now we've got that sort of 63 for 9 bags of apples. Now, if I'm in a higher grade level, maybe I might not do this many in third grade because it's going to take me a little bit longer. But if I'm at a higher grade level, I've got kids that sort of know some of the facts, then I might end this problem string with something like 19 bags of apples. Pam, nobody needs to know 19 times 7. I know. But my point is, if I use a ratio table like this, I've already got kids to a place where they can start thinking about all multiplication, like not just single digit multiplication, but any multiplication. I can just use what I know, the chunks I know, and I've got them in a ratio table. I can just kind of use those to solve anything like 19. Can I just add the 10 bags and the 9 bags to get 19? Well, what is 70 and 63? Now, I might want to think about that a little bit. Like, I might want to think about 70. Let's see, 70 and 60. Well, I could do 70 and 30. That's 100. Let's say I needed to add 63. What do I have left? I've got 33 left. What is 133? Is that just 133? That's like my favorite question when the question is the answer. Bam! And I've got kids realizing it's not just about this rote memory of single-digit facts. Multiplication is figure-outable. And I'm giving them experience reasoning about all these facts with lots of different relationships so that they get the best of both worlds. They understand what's going on and they get some really good practice. I want both of those things to really help kids automatize the multiplication facts. So let's see. I love I Have, You Need. Tara, yep, woohoo. And same with Laura. Yeah, my third graders love I Have, You Need. Absolutely. Velvet, nice to see some friends on tonight. Excellent, you guys. Love the repeated reasoning, use of structure, do 19 times 7. You bet, Corey. I totally agree. So then could I do something similar, but with one day I come in, hey guys, we're going to do a quick problem string. And today we're going to talk about cartons of pencils. I've got these cartons of pencils. In each carton, I've got 6 pencils. And then I might ask them, hey guys, how many would 10 cartons have? Now, I would only do this if kids have started playing around with that 10 pattern. And then they're like, oh, well, that'd be 60 pencils. Yeah, we've been playing with that 10 pattern. Okay, guys, how many pencils are in 5 cartons? Like, what do you got? And then see if kids can go, well, I mean, that's just half. Could we just half that? Sure enough. So is 5 6 30? Whoa, totally cool. If I have 5 cartons, do I have 30 pencils? Could I then ask them, how about 6 cartons? Can you see the relationships I'm trying to nudge here? I'm trying to nudge kids to use some really helpful things in our number system. Do you know that you can think about 5 times anything? as 10 times that thing and half it? Like, how cool is that? I'll tell you what, my personal kid taught me that strategy. I was a high school math teacher, had no numeracy. And one day he's like, yeah, you don't have to memorize your fives if you know your tens. Cool beans. Well, what if I were to then ask you, what's 6 times anything? Could you find 10 of them? Because we know the times 10 pattern, find half of that to get 5 of them, and then just add 1 back to get 6 of them? What is 30 and that 1 more carton of 6 pencils? Is that just 36? Because I added 1 carton, so I have to add 6 pencils. Sure enough, woohoo! And now all of a sudden I got kids thinking about 6s. Could I then ask, let me clean this up a little bit. So this is a different problem string. I'm just putting things in a different order, trying to get kids thinking about different relationships. Could I also ask about 11 cartons? I don't know. Is there anything up there that you could use? Well, you guys look at that for a second before I go on. Got a sore throat. I'm going to put a Ricola in my mouth. Thanks for that. Those of you that know me know I always have a sore throat. It's not COVID. Not that you could get it over the Facebook Live. Can you make a sticker that says math is forgettable? So totally. And Tara, you have to tell me how to say your name. Is it Tara, Tara? Because I want to say it right. We are working on some swag. It is in the plan. Stay tuned. If you want to know more, check out mathisforgettable.com. Get on the email list. As soon as we get the swag coming out, I will let you guys know. We're going to have stickers, laptop stickers, shirts, sweatshirts, bags. I mean, all sorts of math is figureoutable kind of cool things. So coming, totally coming. All right. So could I, after you, what relationships could we use to get the number of pencils in? 11 cartons? Well, could a kid use 10 and 1? That's already up there. Could they use 5 and 6? Bam! Like lots of different kinds of relationships. And so then they would find 66. Now I'm going to notice that pattern. Hey, that's interesting. 11 times 6 is 66. You guys, I might put a poster up on my wall somewhere where I just kind of put noticings. Maybe one poster has all the times 10 noticings. Maybe another poster has the times 11 noticings until kids start to go, whoa, there's these patterns that we can just use. Absolutely. I want a large. Awesome, Corey. All right. You bet. We're working on it. We're working on it. Okay. So after I ask 11, could I ask for 12? Hey, you guys, don't get too stuck. Are there some other relationships that you could use up here to get 12 cartons of pencil? How many pencils in 12 cartons? How many different ones can you find? Now, notice that kids are now looking for different relationships. And then after somebody says, ooh, I could just double the 6s. And somebody else says, I could add 11 and 1. And somebody else says, I could add, help me, 10. And if I just knew 2 of them were 12, I could add the 10 and the 2 together. Then you might say, hey guys, if you're walking down the street and you just run into this fact, I need 12 cartons that have 6 pencils in them. I need to know how many total pencils that is. You're walking down the street, you just need to know that. Maybe you don't have this whole table to help you. Which one of those relationships that we just talked about, which one do you want to just grab and use when you don't have any of the other ones? You don't have this table in front of you. Which one do you want to use? Now, that's a great conversation for kids because now here in the string, they're sort of playing with all the relationships. They have them all up on the board they can use. Now you're asking them, what if you don't have those? Which ones can you easily recreate while you're walking down the street and you run into that fact? That's a brilliant conversation because what you're really asking them is, when you need to know that fact, what relationships do you own that you could quickly use to find that fact? Y'all, I did a posters with noticings. Woo! I did some interviewing of some 4th grade kids once, and it was really interesting. Kim, if you've heard me ever talk about Kim, was their teacher. And I worked with a kid who was a little bit of a slower processor, a brilliant kid. And as I asked him, I think it was 11 times 12. He figured it out by thinking about 10 12s and added 1 more 12 to get 11 12s. But I'd also asked his classmate just a minute before, what's 11 times 12? And she just smiled and said, oh yeah, I know that one's 120 or 132. And I was like, how do you know that? And she's like, we work with 12s a lot. So what we kind of want is we want that to happen. We want to have it happen where kids work with facts a lot and they just become automatic. But if they don't happen to know one, they confidently can use what they know to figure it out. Let me give you the rest of this problem string. So I might end at any time as soon as I've taken 10 to 15 to 20 minutes. I don't want it to belabor. But if I've got older kids, then I might be thinking about, let's see, we never did find 12. Is that 72? And then I might end this string by asking for 17. cartons of pencils. Could they use some relationship there up there to find the number of pencils in 17? I'll let you guys think about that. I'm looking at the time. Oh, and I got to get going. So let's do one more problem string. I might say, hey guys, I've got a box of, I don't know, whatever you want to put in them, cookies, or pick your thing that kids can sort of deal with. And I might say, in that box, I've got 8 cookies. So how many would 2 boxes have? Now, we're not going to take the time to do all these, but I'll just throw out this number sequence. After I found 2 of them, could we find 3 of them? That we need to know that 3 times anything is 2 times that thing plus 1 more, right? So I might do that. And then I might ask kids, well, how about 6 of them? Ooh, can you see that? So kids might, what, double the 3? Nice. They might triple the 2. Nice. They might add up the 1, the 2, and the 3 to get 6. Lots of different relationships. And then again, we step aside and we have a conversation about that. And pretty soon kids are just like, Miss, it's just 48. We just know, like six boxes with 8 cookies, it's 48, because they have all these ways that they've been thinking about it. Then from there, I might ask them, well, what about 12 boxes? Any relationships there? Could we double the 6 to get to 12? Then I might back up to 11. Could you think about the 11? Again, I'm going to have a noticing when that happens, right? When that 88 pops out. Hey, there's another one. That's kind of cool. Put it up on that 11 noticing poster. Then at the very end of that string, I might ask them for something like 23 boxes. How many cookies are in 23 boxes? So lots of different ways that we can think about using ratio tables with problem strings. Remember how we wrote it here? Or problem strings with ratio tables, either way, in context to help kids really understand what's going on and get some good practice. All right, let's talk about, that was way number 1. Way number 2, I'm going to have to go kind of fast here. I've got kind of a hard stop in just a few minutes. So way number 2 is I want to help kids think about, you might find this a little bit interesting that I'm going to recommend this, but I'm going to recommend flashcards. But I'm not going to call them flashcards. I'm going to call them clue cards. What do I mean by that? Well, I'm literally going to take kids, get them going, doing something really good, some really good math game or whatever, and I'm going to individually interview my kids and students, and I'm going to say to them, here's a deck of flashcards, and as they go through, I'm going to hold them up and I'm going to, do you know this one? And I'm going to make 2 piles. Facts that, let's say I'm interviewing, I don't know, Steve. Facts Steve knows. Facts Steve doesn't know yet. Facts Steve knows, facts Steve doesn't know yet. And I'm literally just going to interview Steve, and as I see which facts he knows, I put him in that pile. Facts he doesn't know, I put him in the other pile. So facts you know and facts not yet. Then I'm going to take that pile, and in that pile, I'm going to make a personal set of flashcards just for Steve. And we're going to go with that facts that Steve doesn't know yet. And let's say Steve doesn't know 6 times 7. That's a most missed fact. A lot of kids don't know it. I'm going to just take, you guys random, just like blank index cards, cheap. And I'm going to do 6 times 7, 7 times 6. And then I'm going to say to Steve, hey, Steve, when we did these ratio table problem strings and we did 6 7s, well, I don't have that one up here, but I'll maybe point to one or in the middle of it. I'll say, what clue worked well for you? Like, how could you figure that out? What kind of, now, you know what my favorite clue for 6 times 7 is? Right. Is I want kids to think about 3 7s and then double it. Once I have 3 7s, well, 3 7s is just 21, right? And you guys, everybody can double 21. And so that's a great way to think about it. So I might say to Steve, does that clue work for you? That works for you. Great, super. And then I'm just going to put just what Steve needs. Now, Steve might need 3 times 7 is 21. I kind of don't usually want to give that much. I'm going to try to just like give just a little bit, just like what could I give? I might need to write down a little bit more, like 3 times 7 plus 3 times 7. Or depending on how you want to write that, maybe 2, 3, some hint. I could potentially draw, I kind of didn't leave room here. What if I could potentially draw like that 6 by 7. Make sure that's a rectangle because 6 by 7 should be a rectangle. And then I could go like this, and I could go 3. That could be the way that I write the clue. Whatever it is, so that kids go, so that I create that individual clue card set for kids. Y'all, and then send it home with parents and say, hey, parents, here is your own kid's personal clue card set. Work with them with the clues. Like, help your kid explain what's going on. By the way, I would do this with kids enough at school that your students were very confident that they know what the gig is for clue cards. And then when you send them home, they can clearly teach their parents why there's clues on them so they can use those to help them refigure the facts. Let's see what you guys are. Love clue cards. Woo! I love asking my sixth graders, how do you know that? Yeah, nice. I totally agree. Tara, did you tell me how to say your name? I want to know how to say your name. Anyway, okay, moving on. That's number 2. So I think we can provide kids practice with clue cards, but it's intentional, good practice. It's not rote memory practice. It's practice based on relationships, practice based on understanding what's happening, and then good relationships to figure those facts. All right, you guys, ready for number 3? This is so cool. All right, way number 3 tonight, and I've got a couple minutes to do this, so hopefully I can give it some justice here. It's a game called Stick and Split. Y'all, I don't advocate very many games out there. I have a few that are just like really cool games. Stick and Split is a game that has just come out, and I think it's amazing. And right now, the creator of Stick and Split is offering an unbelievable deal for teachers. So I'm going to tell you about that in just a second. So hold on just a second. This is Stick and Split on my iPad. Now, is this still Pam Harris playing? Yes. Okay, so this is literally my account, and I just sort of skipped to a level that I thought would be kind of cool. I don't want them to make a move for me. So we need to make 18s. Can you see that 18 at the top? That 18 at the top says we need to make 18s. How could I make 18s? Well, I could get a 3 and a 3 and another 3 and 4 3s, 5 3s, 6 3s. 6 3s would make 18, right? So I'm going to stick those. Notice at the very bottom where it says stick, I'm going to stick those. Bam! I've got 18. Okay. How else could I make 18? Anybody notice those 5s? What in the world am I going to do with 5s to make 18? I'm going to have to really think about that. Like, could I do 3 5s? Why would I do that? I'm going to stick those together. That's going to make 15. Now I'm going to take that 15 and watch what I'm going to do. I'm going to split that 15. Okay, guys, what makes sense to split that 15? Into 3 5s or 5 3s? Like, what would be helpful? Because remember, what's my goal? My goal is to make 18. And oh, don't make a move for me. It's cool that it will say like if you pause like we are, make a move for you. But let's go ahead and split that 15. Okay, again, into 3 5s, 5 3. I'm going to split it into 5 3s. Now I get a bunch of 3s. How many 3s do I need to make 18? I got to get me another 3, right? What can I do to get some more 3s? In fact, what am I going to do with those 4s? How am I going to make those 4? And so this is like a really cool game. Now there are other ways to, let me actually just show you let me see the time. Oh, running out of time. Let me just show you really fast. I can go to levels here, and let me just show you that there are places where literally I'm making 18 again, but I'm literally just learning what makes 18s. So I'm going to stick those 2 9s. I'm going to stick these 2 9s. I'm going to stick, notice how I'm just sort of getting a lot of practice in making 18. And in fact, if you looked at when I hit level over here, all these levels, the levels are all based on making those totals. Like make a 14 at the top right there. Make a 15 right there. Make a 16. You guys, let me tell you what kind of happens when kids start playing Stick and Split. First of all, they like it. They're interested in it. It's fun. They do it. They keep going. They can earn these little diamonds if they do things in cool ways. In fact, Sue's on here tonight. Sue's kid said, "Hey, Mom, I figured out a new way to make 15. How cool is that? Like, it's all about sort of thinking about how to make these products, and the kids kind of deal with those smaller products before then they go up to like bigger and bigger products. Notice how the products are getting bigger as I go up the game. So you deal with the products that are small, and then the products get bigger. Y'all, I think this guy's onto something. So how can you get involved in, Mariana's Stick and Split, kind of addicted, right? It's kind of addictive. How can you get involved? You can go to Stick and Split on Facebook or on Twitter, private message, direct message the guy and say, I would like to have, are you ready? I would like to have a free account for schools. You will get a free teacher account. He says forever to use with your students because he's trying to collect data. So I think it's an unreal deal. I think it's absolutely unreal deal. Just look up Stick and Split, contact the creator and say, Pam Harris told me about this deal. I think he has you get on like a 10 to 15 minute Zoom call because he wants you to actually use it so he can actually get data. I've talked to lots of people that say it's very painless. I've actually met the guy. He's really nice. Talks to you for a few minutes, tells you, I can get you all going. You can use it with your students. And I think it's amazing. So I highly recommend Stick and Split. I think it is a fabulous, real math game to teach real math. Okay, you guys, I promise you a surprise if you want to learn more. Thanks so much for being on tonight. If you would like to know more about how to teach math that is figure outable, the facts that are figure outable, we couldn't do everything tonight with facts. There's lots of other good things. However, if you want to know more about ratio tables, so we did some problem strings with ratio tables, I've got a webinar for you. So a live free webinar coming up this Friday and Saturday, January 22nd and January 23rd. You have to sign up for that one. So Facebook Lives, you can just pop on. Come on as you want to. You can watch the replays on Facebook, no problem. We also put them on my YouTube channel. But the live webinar, you've got to register for. So where do you register for that? Let me put that on there really fast. So I just put the link to register the webinar in the chat. I will also put it along the bottom here. So there is the link to register for the webinar. I'd love to see you in the webinar. Y'all, with that math model called a ratio table, I will show you much more than multiplying with single digits. We will multiply with whole numbers and decimals. We will divide with whole numbers and decimals. We will solve proportions with whole numbers and decimals. We'll even do some fraction work. So ratio tables are amazing. If you want to know more about how to teach real math with ratio tables, I invite you to join me on the free webinar. Make sure that you register. Love to see you. If you can't make it at those times, register anyway, and I'll send you the link to the recording. All right, you guys, I hope you enjoyed tonight's crazy fast fact webinar. All the best. Make it through this year, you guys. You can do it. You can do it. Take care.